Greatest common factor and least common multiple. You have learned how to do those. We've been practicing in class. And now we're going to take it one step further by solving some word problems. Sometimes you have to find the greatest common factor and sometimes you have to find the least common multiple. And it seems to be difficult for students, so I'm going to offer you some strategies that hopefully you'll be able to implement that will make it something you can be successful at. The first thing you're going to ask yourself after you've read the word problem in its entirety is, do I see a keyword that helps me decide if it's greatest common factor or least common multiple? Greatest common factor would have the word greatest or most or highest. Those are some keywords you might find. Least common multiple would be least or shortest or minimum. Those are some things that would help you with least common multiple. Now, I'm not going to tell you that they're always there, but most of the time they are. And then you're going to ask yourself, is my answer to the actual problem going to be a number that's bigger or a number that's smaller than the rest of the problem? And if you look at how I wrote these words, factor produces a smaller answer, and multiple produces a larger answer. Factor small, multiple large. That will help us as we solve these 5 word problems. Boxes that are 10 inches tall are being stacked beside boxes that are 15 inches tall. What is the shortest height in which the stacks will be the same? The key word that stands out to me there is shortest, which makes me think least. So I'm going to remember that I think it's the least. And then I'm going to ask myself, 10 and 15 are my numbers, and I'm looking to stack those boxes. Does it make sense that my numbers would be smaller? Could I have a stack smaller than 10 inches? No. My stack is going to be large, which means that I'm going to find a multiple, because multiples get larger. So if you can see here, this is telling me that I'm going to find the least common multiple. Now that I've gone through the question process, I'm going to do it. 10 and 15, least common multiple, 10, 20, 30, 15, 30. So 30, and then I have to find the label. What is the shortest height? A height is a measurement. So 30 inches would be the shortest height of the boxes. Let's try another one. Inquire, there are 48 boys and 64 girls. If Mrs. Breen needs rows with equal amounts of boys and girls, what's the greatest number of rows she can make? I'm asking myself for that keyword, and the keyword that I see here is greatest. And now I'm asking myself, do I want more rows than I have boys or than I have girls? And the answer is no, I want less. So I want a smaller number. So I'm looking for greatest, and factor is the one that yields a smaller number. So if you look here, this is telling me that I am looking at the greatest common factor. The greatest common factor, you have 2 options. You can make T's or you can make trees. 48 happens to be 2 times 3 times 2 times 2 times 2. And 64 happens to be 6 sets of 2. That's my prime factorization. You could have gone to a separate page and done that. I'm just doing this for the sake of time. So my greatest common factor would be what would go inside of my Venn diagram. 1, 2, 3, 4, 1, 2, 3, 4. 4 2's go in here, and 2 to the 4th power is 16. So Miss Breen could make 16 rows. Each row would have 4 girls and 3 boys. Gracie is baking cookies. She's got 30 oatmeal and 45 chocolate. What's the greatest number of bags she can equally fill with the same amount of cookies? Well, here is my keyword, greatest. And then I'm asking myself, do I want More bags, will I end up with more bags than cookies? And the answer is definitely not. I'm looking for a smaller number, so I'm going to put factor. And this is my key that I need, the GCF. So I'm going to do 30 and 45. The factors of 30 end up to be a 2 and a 3 and a 5. And 45 end up to be a 3 and a 3 and a 5. And so when I put those in my Venn diagram, what I have in common is the 3 and the 5. That means that Gracie will be able to fill 15 bags. And each bag will have 2 oatmeal and 3 chocolate chip. All right. Pencils come in packs of 5. Erasers come in packs of 6. What's the smallest amount of each that I should purchase so that I don't have any left over? I want a pencil for each eraser. Well, does it make sense that I'm going to... Well, first of all, let's look at our keyword, smallest. So that tells me least. But then I ask myself, does it make sense that I would have less than 5 pencils or less than 6 erasers? No. So the number's going to be bigger. So I'm finding the LCM. So I might say the LCM of 5 and 6. This is a 5, and this is a 2 and a 3. And if you'll notice, there's nothing in common. So 2 and 3 and 5 multiplied together is 30. So I need to buy at least 30 pencils and 30 erasers. All right, Ross takes a bathroom break every 15 minutes, and Schrader takes one every 20 minutes. How many minutes pass before they're in the hall together? Now, this one doesn't have a least or a minimum or a smallest, so we don't have that clue, but we can ask ourselves, are they going to see themselves in less than 15 minutes? Are they going to see each other in less than 15 minutes or more? It's going to be more, and so because multiple is more, that is enough of a clue to know that we have to find the least common multiple. Finding the least common multiple, 15 is 3 and 5, and 20 is 2 and 2 and 5. And so the least common multiple says that we should put 5 here, and this is a 3, and this is a 2 and a 2. And so 15 times 2 is 30, and 30 times 2 is 60. That means that Schrader and Ross will be in the hallway together every 60 minutes. Solving word problems. Ask yourself 2 questions, and then you do what you know with greatest common factor and least common multiple.